This is a restricted aerospace manufacturing facility where military aircraft production begins.
Every person and every component entering this factory is digitally verified.
This main hall is where the structural build of military aircraft takes place.
These robotic systems weld aircraft frames with extreme aerospace precision. Every surface here is inspected before it becomes part of an aircraft.
Few people ever enter facilities like this. Today, we go inside a real high-security factory where military aircraft are built. Military aircraft are built from aerospace-grade metals and advanced composites.
These materials are scanned to detect microscopic structural defects.
Once verified, the materials are prepared for industrial shaping.
Heat treatment increases strength and fatigue resistance in aircraft metals.
Chemical processing protects aircraft components from corrosion.
These sheets will become structural aircraft panels.
Laser systems measure every surface down to microscopic tolerances.
Surface finishing improves both aerodynamic performance and structural bonding.
Each component is digitally registered into the manufacturing system.
This entire section prepares the foundation of every military aircraft.
Hidden fractures are detected before production can continue.
These prepared parts are transferred to the forming division.
Each aircraft component is tracked throughout the entire factory.
This is where raw material begins transforming into aircraft structure.
These hydraulic presses form the primary skeleton of the aircraft.
Every curve is engineered to control airflow and structural strength. Composite systems balance strength with weight reduction.
Thousands of precision holes are created for structural assembly. These systems verify stress distribution before assembly begins.
Formed structures now move into precision machining.
CNC machines refine components to aerospace tolerances.
Each cut removes material within microscopic limits.
All departments operate on synchronized aircraft production cycles.
These ribs distribute flight loads across the aircraft frame.
Weld integrity is essential to aircraft survivability.
These assemblies are transferred for precision engineering.
This department handles the most sensitive aircraft components. Here, aircraft parts are refined to their final structural form. These machines produce flight-critical components to exact specifications.
Material removal here is measured in microns.
Robotic machining ensures consistency across all aircraft units.
Laser shaping produces components without mechanical stress.
These openings support internal control and hydraulic systems.
Manual calibration fine-tunes what machines cannot detect.
Hidden flaws are identified before components advance.
Smooth tolerances reduce vibration and stress concentration.
Each component must meet aerospace dimensional standards.
Oh, that's it.
These finished parts are prepared for aircraft integration. Automated handling prevents human contamination or damage.
Only approved components are released for assembly.
Now the aircraft begins structural integration.
This is separate components. Those components become an aircraft.
These fuselage sections are aligned before permanent structural joining.
Structural joints carry the main flight loads of the aircraft.
Robotic systems ensure uniform fastening across the airframe.
Wing structures are integrated with millimeter-level alignment.
These reinforcements distribute stress throughout the aircraft.
Hydraulic systems power flight control and landing mechanisms. Electrical networks link every onboard aircraft system.
These modules manage navigation, communication, and flight data.
Propulsion systems are integrated after structural validation.
Landing systems must withstand extreme operational stress.
The cockpit frame protects flight crews and avionics.
These panels restore aerodynamic continuity. The aircraft now functions as a unified structure.
Next, the aircraft enters full validation and testing.
This phase verifies whether the airframe can handle operational forces.
These systems simulate the extreme loads experienced during flight.
Real-time sensors record structural response at every point.
Landing gear assemblies are tested for impact endurance.
All mechanical and structural data is reviewed before proceeding.
These systems regulate navigation, stability, and pilot response.
Electrical systems are verified to prevent in-flight failures. This chamber simulates extreme altitude and temperature conditions.
These tests confirm operational reliability under combat environments.
Vibration testing replicates high speed and turbulent stress.
Every surface and joint is inspected for imperfections. Only certified aircraft are cleared to exit testing.
After validation, The aircraft moves to final preparation.
This aircraft has passed full industrial quality verification.
Final sealing begins once the aircraft has passed all testing stages.
These seals protect internal systems from pressure and moisture. The airframe is prepared for advanced protective coatings. These coatings improve durability and reduce operational signatures.
Every external surface is reviewed before deployment approval.
Completed aircraft are stored in secured operational hangars.
These systems prepare the aircraft for operational readiness. Final system checks confirm full aircraft functionality.
This aircraft is now approved for deployment preparation.
Transport teams prepare the aircraft for final transfer.
The aircraft is now entering operational staging.
This entire facility exists to support military aviation readiness.
And this is how military aircraft are built and pivoted from raw materials to industrial reality. This facility transforms engineering into operational air power.